Hi, and welcome to From State Management to ReactQuery. I'm Adam Klein. I'm the co-founder and CTO of Cover, which is a startup doing really cool things in the employee engagement space. I'm also a father of two, and I like dad jokes. I'm also a WebGDE and the author of Reusable JS, which is a library for state management of client state in React using hooks. So when we say state management, we usually think of a single source of truth, uh, from which we infer that all of our state needs to be handled in the same place in the same way. But not all states are created equally. So our client state is synchronous. It's up to date, it's complete, it's consistent, and usually cannot be changed elsewhere. But our server state, on the other hand, is asynchronous. It's stale, it's incomplete, it might be inconsistent, and usually can be changed elsewhere. So our server state really needs a lot of special care, like loading states, error handling, caching, invalidation of the cache, deduping of requests, refetching, prefetching, pagination, infinite scroll, optimistic updates, etc., etc. And you might notice that all of this list is pretty generic. It's not specific to your application or your business logic. So why do we keep re-implementing this inside our state management solution for every project? Well, because we want a single source of truth. We want to manage all of our state using the same solution, whether it's server state or client state. And I used to say this as well, and I used to promote this approach as well, and it's one architecture that you can follow. But I'm here to tell you that you don't have to. You can do it otherwise. There are obviously pros and cons, and I'm going to show you what it looks like with the new architecture. So with the new architecture, you use a library like ReactQuery that manages the state of the data you get from the server inside of the library. And so the actual single source of truth of your server data is your server or your database. And your local representation is just a cache. And ReactQuery treats it as a cache. And your client state is actually your source of truth for your client state. So they will be managed in two different locations. And you can always combine them if you want inside your component or some custom hook. So ReactQuery actually handles everything that we discussed and many more. And the only thing that it doesn't do is the actual call to your API, because your API is specific to your application. So it just expects you to return some kind of promise, and you can do the actual API call using fetch, Axios, some third-party SDK. You can use REST API, GraphQL, or whatever you want, as long as you give back a promise. So let's look at the code. Sorry about that. Okay, so this is an application showing notes, and we can browse through the notes and see the actual content, and we can look at the list of notes, and we can also add a new note. And we will navigate to the page displaying this note. Now, you already noticed that we have some bugs. And also, let's look what happens when we refresh the application. We fetch notes twice because we need them inside our sidebar, and we also need them inside our main page. Also, if we navigate to a note and then back to all notes, we keep reloading the data from the server, even though we just visited this page. So why not cache the data and display it and fetch the data, the new data on the background? Well, let's use ReactQuery and we can get this for free. So first of all, to use ReactQuery, you need the query client provider and provide a query client, which we already did. Now let's go to our node queries and see what goes on here. So our sidebar calls use nodes, and our nodes also calls use nodes. And which explains why we make the API call twice, because we don't really cache the promise and make sure not to make the request again if it was already done and if it's currently used by any other component. And as you can see, we managed the loading state and the error by ourselves. And you might not notice that we have actually a bug because we use different states for our data, our loading, and our error. We can have inconsistent states of our data and our UI. So for example, we start with is loading false, but we also start with no data. And we also have, we set the data before we set is loading to false, which means we will have these very quick but inconsistent states of our UI. Either we have loading is false but no data, or we have data but loading is still true. And then we will encounter these weird bugs which we will bypass like this. So here we say if it's loading or there are still no nodes. So let's see how we solve all of this with a ReactQuery. So to use a query, you probably guessed, we use query. Now use query gets two parameters. One, the first one is the cache key. So this will be used by ReactQuery to know that if we make this call twice, it means that it's the same query and it can use the cache. The second parameter is the actual function that, fetch nodes, that does the actual fetching from the server. So let's move it here. And we really don't need anything else. We don't need all of this. We can just return the result, and that's it. So ReactQuery manages everything around this query for us: is loading, is fetching, error states, etc. And so when we get back the result from ReactQuery, we get a data property. So let's map it to our local nodes variable, and we'll do the same inside our sidebar component. So it was pretty convenient because I already used a data structure that is similar to what ReactQuery returns. But anyway, the refactoring should be quite easy. So now, first of all, let's see what we got here. And let's refresh. And as you can see, we only fetched nodes once from the server and used them twice in our UI. That's because we used the cache key. What else did we gain? If we go to one of the nodes and go back to all of the nodes, it's already cached. So we display it immediately. However, you probably noticed that we display it, but we fetch it again from the server because something might have changed. So ReactQuery always assumes that data is stale and it needs to be refetched. You can also override this behavior and tell it, give it some timeout to say that if in the next 5 minutes you don't need to refresh this data from the server. So let's do the same for our single node that we fetch from the server. And the reason we fetch a single node is because our nodes query only returns the ID and the title. We want to save bandwidth. But when we go to a specific node, we want to fetch the body as well. So when we fetch a specific node, we're going to do pretty much the same or something very similar, except the query is different, obviously, because it needs to fetch a single node. And let's call this fetch node. And the query key is going to contain the node ID, because it needs to be unique. If we fetch a different node, we don't want to use this node, we want to use the other one. So this is a unique ID for the request that gets this node from the server. Now, I usually add this prefix here, because later on we might want to have other query keys that start with node, for example, like a filter. And then if we do something like this, this might clash with the ID. So I prefer to do it with another prefix saying that this is a single node. You can also call it single or whatever. And now let's go to our node component. And when we use the node, again, we map the data to our local node variable. And let's see that it works. So we start from all nodes, we navigate to a node, it's loading. But if we navigate to it again, it's getting the data from the cache. So it's not browser cache, it's just cached inside the memory of ReactQuery. Now this cache is very smart. First of all, it knows if you're observing it, if there's any component on the screen that uses the cache. If not, it will be garbage collected. There's also a timeout. So if you're to avoid the memory leaks, so it won't save things forever inside the cache. Obviously, you can control all of these parameters. And also notice that we can remove this bypass that we had for the bug, the inconsistency bug that we had before. Because now we can have a state that it's loading and also there is no data. ReactQuery makes sure that the loading state is always consistent. All right. Now let's do another cool thing that ReactQuery allows us, and that is to show some kind of fetching indication in the background. Because as you can see, when we navigate, we show data from the cache, but we are still syncing from the server in the background. So we might want to display it in the level of the app. So I already prepared this component here called fetching indicator. And ReactQuery gives us this nice hook called use this fetching, which tells us, is there anything fetching in the background or mutating? So as you can see, when I navigate between posts and I go notes and I go back to a note I already visited, we get this nice syncing indicator in the background. Okay, let's see how we add a note. So now we added the node, but it's not added to the list because the list was fetched once from the server and that's it. So let's go back to our node queries and fix use create node. Now, when we change something on the server, it's a bit different than fetching because we're not going to cache anything. So instead of using a query, we're going to use a mutation. And the mutation doesn't receive a cache key because we're not caching anything. It just gets the actual function that will do the mutation. And this function receives an input. Create node input. And let's move this function here. And again, we can get rid of all of this logic that we had before. And we don't need try and catch. We don't need to set loading. It's so fun removing code. And we can just return whatever we got back. So now let's go back to our node component. And here we don't really need the data that comes back. We just need a function called mutate async. Mutate async lets us do the actual mutation. Because As opposed to queries, we don't want to perform this mutation immediately when the component mounts. We want to do it on some kind of user input or user event. I think I'm in the wrong component, yeah. So instead of create nodes, we will have mutate async, which is the function that mutates state. Not mutates the state, it does the mutation on the server. And we can actually do this. So we call this mutate async, and we get back whatever the server returned, which is the new node. And now we don't need this effect. We can just do an async flow using async await, instead of responding to the new data that came back from the server and got saved on our local state. So there we go. And we use the new node ID. So now when we create the node on the server, we get back the new node that was just created, and we navigate to the nodes. But we still need to update the list of nodes somehow. So the easiest, most straightforward, and most error-prone way to do this is to just refetch the entire list. And the way we do it is we specify an onSuccess handler. So ReactQuery gives us these lifecycle hooks on success, on error, on settled, on mutate. So we can do stuff during these lifecycle events. For example, we can invalidate the nodes query. How do we do that? We get the query client from use query client, and then we call invalidate queries and pass in the query key. So this will actually invalidate all of the queries that start from nodes. So it will also invalidate a single node if we are displaying it on the screen. And if we had other queries like filters or pagination that start from nodes, it will also invalidate them. If we want just to invalidate this specific code, we can do exact true and just invalidate the specific cache key. Okay, let's see if it works. Let's refresh, add a node, and newly added nodes. We save it, and we refetch the entire list, and we can see it on the sidebar. So it's already a much better experience and fix the bug. We can even go one step further, and as you can see, it takes a bit of time before we get this newly added node here, because we have 2 round trips to the server. We create the node, we get it back, and then we go to the server again to fetch the entire list and get it back. So it's the safest way, but we can have a shortcut that will save us this round trip, the second round trip. And so what we can do is we can actually access the cache that ReactQuery holds for us. So we call query client.set query data. So we're going to actually change the cache that is saved inside ReactQuery. And the way we do it is with an updater function, just like setState works. So we get the old nodes. And we ask if old nodes, return old nodes, and then we need to get somehow the newly created node, which we get here on the onSuccess handler. So new node. And so just to recap, we are updating the local cache immediately. We take whatever was there before, and we concatenate the new node that we just got back from the server. And else we can just return old nodes. So this is just an edge case in case we still don't have any array of nodes. It's always good to handle edge cases. So this should be updated immediately. Let's see. We save it, and it's updated immediately inside the list. Now you might notice that I still left this invalidate queries, and that's because, as I mentioned, in this new architecture, we rely heavily on the server to be our single source of truth. So whenever we do cache updates and local updates, they are only temporary until we get back the data from the server. This is always a good practice to do, to have a fallback of invalidating the queries that might have changed. If you want to take this one step further, ReactQuery also supports optimistic updates. We won't show this now, but there is a way to do it. It requires another step, and it probably requires you to create some kind of ID, like a unique ID on the client. And basically, you specify on mutate, and you update the query cache immediately when you mutate. You don't wait for the response from the server. But obviously, then you have to handle errors. You have to roll back to the previous state. So it's a bit more complex, but it's supported inside ReactQuery, and they have recipes on the website to show us how to do it. Cool. So the last thing I want to show you is the DevTools. As you can see, ReactQuery comes with built-in DevTools. You got this little fella over here. And when you open it, you can see all of the queries that pass through ReactQuery. You can see whether they are stale or fetching or fresh. And you can also examine the query cache, the query key, I'm sorry, and the actual cached data. And all the config variables that we pass to React to this query. So this is very useful for debugging and examining the data that you have inside your cache. Wow, so we got a lot of stuff from ReactQuery out of the box. It's pretty simple to use, and it takes some time to get used to this new architecture, but you'll find that in most cases, it works very well. Obviously, you need to examine if it works well for your application. You might have a very custom workflow or data fetching strategy, in which case you should still consider using ReactQuery. And for example, if you want to normalize all of the data, which is something that's usually very difficult to do and is only needed in a very few cases, you can still do it with ReactQuery. But this architecture basically says, rely on your server. You need to have a strong server that can return results with a low latency and handle all of these requests. And then you can do these caching strategies, update local cache, but always refetch from the server. And ReactQuery, as you can see, is simple, it's consistent, it's tested, and it's TypeScript ready. It's got great UX out of the box with reduced bandwidth. And you have a lot of control of all of the parameters and all of this data fetching strategy per request. And you also get tools and recipes for more advanced UX flows like pagination, infinite scrolls, optimistic updates, server-side rendering, etc., etc. So it's really great. We use it. I hope you will use it as well, and I hope you enjoyed this talk. And if you have any questions, let me know. There's also a Git repository with the code for this demonstration and the solution for it. Goodbye.